Okay, well, I think we can begin. Welcome everyone again for those of you who just joined to our webinar on converting and transforming technical graphics. Our agenda today is we're going to start with of course the introduction, which we just done, and then I'm going to cover the housekeeping rules or procedures that we use, and then give you a quick company overview for those of you who don't know Larson software technology. And then we'll jump into the slides and presentation, and which will have a few experts there, and then a summary where we're going to summarize for you. And okay, hello everyone. We seem to have some technical difficulties there, some internet problems. So hopefully you can all hear me again. I just gave you the brief agenda, and the rules and procedures we use for this webinar today is that all attendees will be muted for the duration of the webinar. If you experience any problems when joining, you can use this little chat window down there to communicate with us, give us feedback, and we'll also have some handouts. We've got a little green arrow there drawing your attention to these little PDF and graphic handouts pertaining to the information we're presenting today, and feel free to just drag and drop those onto your desktop if you find something of interest there. And then post your questions during the webinar in the little chat panel. Wait to the end to actually answer your questions.
Hi, Don, it's David. We had another issue with your sound then, so do you want to switch over to me?
Yeah, so I'm going to switch. I seem to be having internet problems on my side, so we're going to switch it over to Dave, as he just said. So
okay.
So here we go. So
thanks, Don. If you just
okay.
if you just go on mute, because there was also some kind of disturbance on the line as well. So thanks, Don. I'm the guest presenter, so I'm on a bit earlier than planned, and hopefully my sound works okay. So as Don was mentioning, we're going to have some interactive polls today, and you can obviously vote on those. We're going to run them in the background. They're live. None of your details are captured, so don't be concern yourself with that. But there's some of the questions that we'll be posing today, so you'll see those appear as we go along. So I'll introduce Larson. Wasn't in the plan, but Don's company is based in Houston, Texas. We're founded in 1984, and really the whole company is founded around the CGM format. So 30 years in business, and really know the whole industry inside out, really. So all around the graphics industry, that is. So with a particular focus on CGM. So the Larson have been promoting the usage of CGM. They released a free reader, CGM viewer, called VisX Reader. So, and you can still download that today, and it also supports TIFF as well. And also they're a member of the CGM Open Foundation, which governs the format. It's an open format, so they govern, that organization governs the format. It's a non-profit organization. And So with the technology that Larson's had, they were very heavily into the, and still are, into the oil and gas industry because CGM was used there, and also aerospace and defense, so forth, as you'll probably know that. So this was the point that was going to pass to me. So I'm David Mannock. My company is Visual Sight, and we've been working with Don and the guys over there to help to present some the software, but also help with some webinars and so forth, which we're going to do today. The actual idea of this webinar came out of chatting to the support guys within the Larson organization, and a lot of their support doesn't always revolve around software. It revolves around files and file formats and handling those. So we decided to try and compile some of that information into a webinar to kind of give to a wider audience, and that's really why we're here today. So the objectives, we're going to transfer some of those lessons learned from transforming technical graphics. We're going to focus on the common graphic source formats, which are predominantly raster and vector, and we separated the webinar into two parts. As you'll see, we did kind of think about actually doing two separate webinars, but kind of time dictates we need to do them all in one, so might be a bit longer today, but I think you'll get a lot out of it. We will describe the data preparation considerations and techniques, some probably you're using already, highlight some of the pitfalls that you might come across, and provide some tips, some of the benefits and advice, and some knowledge around the topics we're talking about today. We'll also at the end obviously summarize the webinar and what we've covered. So the reuse of technical graphics, it could be from various formats, and it can be a significant challenge for some companies. Others obviously have been doing it for some time, so not as much so, but we wanted to try and transfer some of that knowledge to you. Different file formats can present different issues, as you probably know, and the resolutions will probably be different depending on the format. Quality is always a major consideration. You want to put out the best possible output to your customers in the graphical form, so the best quality you possibly can. And we also think that and believe that best practice, which you obviously do as well, will reduce the production time and cost. So if we can do this in an automatic way or in a way that improves the quality and improves the customer experience, then we're going to hopefully reduce costs and then improve things. So as way of introduction, probably look at some of today's ways we actually get the graphical data. So where's it originated? It could have been originated in the past. Could have been scanned in as a legacy illustration, a hard copy. Or probably today it's more likely that it might come from a CAD system, be it 2D or 3D source data. So things are used in spare parts, illustrations, schematics, wiring diagrams. But also you could draw from scratch still. So you could be drawing in an electronic program, that is, the illustration from the beginning. That would depend on the availability and the suitability of the CAD data available. And the other way is actually creating it from a photograph, either using the photograph directly or as a template to trace over. So there's various ways you can still originate the illustration. You'll see on the right we have these little panels with knowledge in, so I'm not going to read those out, but they're there if you'll be able to download the slides after the presentation. So a bit more detail about the possible sources. As we said, that you could have legacy hard copy. This is probably more predominantly in like aerospace, where you have to preserve files for so long, that could have been scanned in from drafting film or whatever. So probably less likely today, but they could still exist. Then we could have raster files that are from intermediate formats. So what I mean by that is that you've exported the raster file from a third-party piece of software, possibly CAD, and also photographs, as I just mentioned a second ago. So we could actually describe that as an intermediate format if we were actually tracing the photograph. And then there's vector graphics. So these could originate from 2D graphic systems, or 3D CAD systems, or 2D CAD systems. But also, as I just mentioned, graphic systems like Adobe Illustrator or Corel Draw. I also mentioned PDF as a separate format because there's a lot of data now held in PDF that you might want to get at. That's where it resides now. So PDF is an interesting topic that we'll talk about a bit later on. So at this point, we're going to run our first poll. As I said, these are all private, so there's nothing captured. So I think Don's going to launch that poll for us. So you should get it should come up on the screen. Just place put your votes in. This is a multiple choice, so you can obviously add more than one answer. There is no right answer. There's no wrong answer. So if you don't use any of these, if you're not really in that industry, then if you're just an interested party today, then you obviously don't have to vote. So we've got about 63% of the attendees voted at the moment. Just give them a few more seconds. You might be ticking all 5 boxes. Okay, 69. Okay, I think we'll. Do you want to end it there, Don? Yeah, so we've got 82% using vector from Adobe Illustrator and PDF, which is interesting. Raster 64%, so not far behind. So they're pretty equal. The one that's the lowest one is probably the one that I thought would be scans from the original illustrations, which is at 36%, but a good spread of actual results there. And we'll put these results out on the slides later on, so you'll be able to actually look at the percentages. So thanks for that, Don. Okay. Hopefully that now has gone away. Did you share it as well, Don? Sorry. Okay. So hopefully it's not on the screen anymore. We just have to remember to actually hide the polls after, because they still populate the screen. Okay, so raster legacy data. It still plays a significant role in the publications process, as we've just witnessed before with a poll. So, and the source could be like photographs or scanned line art, and also it could also be a delivery format as well. So it could be all three. The analysis of raster data can be beneficial. So if you're actually still using it, then perhaps you might want to analyze what you're using to see if you can improve it in some way. And also raster data could actually require hotspotting as well. If we're delivering into an IETM, then we might want to actually hotspot the raster file. So we're going to talk a bit about OCR and how that can help automate that process, so optical character recognition. And raster data can obviously be used as an intermediate format as well, which we spoke about. So it could have been that there was the correct decision at the time, but you might now have alternatives. So you might be able to use a vector instead of a raster file. So this was the lowest common denominator. We still had a percentage of people that were still using scans of old illustrations. So won't kind of labor on this too much, but I would say if you still have access to them and the quality is degraded, then you could be actually better to rescan them. The technology could have improved, so you may want to actually look at that. Okay, so the other thing is that you could actually clean up the original scan or the scan that you have already. If you weren't aware, then the two major kind of dominant Photoshop and the Corel Paint raster editors both have actually functions for removing kind of sporadic pixels, so otherwise known as noise. So these are kind of automated functions within the software, and they have different levels and thresholds you can set. So in Corel Photo Paint, it's remove noise. In Adobe Photoshop, despeckle and dust and scratches. So you could use both of those functions just to clean up the scan. So if you weren't aware there of that. So some of the raster file formats we're looking at. The TIFF is probably the most common, one for line art illustrations. So I would say if you do hold the raster, it's probably going to be in a TIFF format, probably using some compression algorithm to actually reduce the file size. And other raster formats you've probably heard of: JPEG, BMP, PNG, PCX, GIF. Probably the latter four not used very much, but certainly for photographs you'll come across JPEG, and that's probably the predominant one you'll find in your publications. So a quick tip here is that if you're specification compliant, you're perhaps using S1000D, then I would actually save the TIFF as part of a CGM file. One, it will retain its quality and its properties, but also you could combine it with vector data in there as well, and also hotspot information. So if you're holding the TIFF on its own, then perhaps think about going into a CGM file. Another quick tip here is probably you're aware of it, but if you right click on the scan, you can get some more details on it. So you can see it's dots per inch, it's DPI, the size of it, also the compression that's being used. So various bits of information you can get by right clicking on it. I think probably a good baseline for a scan is 300, but you can go down less than that. It's a bit of a balance between quality and file size. So 300 DPI is good. 200, you could probably go down to 200 as well. So at this point we're going to do our first kind of quick demo. Quite ambitious today. We're going to actually show 4 pieces of software. So hopefully everything goes okay. I'm going to check that you're seeing everything all right. So we're just going to do a quick comparison of raster and vector data on the screen. To do that, I'm going to use a Larson product, which is, just check, yeah, we are seeing it. This is a VisX Pro, which is a CGM and TIFF viewer. In fact, it does support other formats as well, like DWG. So I'm just going to open up this is a raster file, this is a TIFF. So I'm just going to open this up. So what I just wanted to highlight here is that if we zoom in, we're going to begin to see the pixels. So, and this is got some gray pixels, which is kind of an anti-alias effect. But as we get really into the, you can see the individual pixels here. This is a 200 DPI scan. So you can see we're going to lose quality. If we're on a display in an IETM perhaps, and we're zooming in, then the farther we go in, the quality will obviously degrade. I've also got a CGM as well here. So let's open that up. And with CGM, we're in the same environment here. If I zoom in, the quality is really going to not degrade, or not degrade as much. So we're going to get much smoother lines. So probably the advice here, if you can use vector, then I would use it instead of raster, if that's possible. It's not always possible, but if it is, then I think it's a good idea. So let's just go back to the slides. So that seemed to go okay. Thank you for that. So the next, so I think it's a good idea to do some analysis of your raster data. You could consider a rescan if you have the original data still available, and increasing that resolution, perhaps from 200 to 300 if it would help. And the other evaluation you might want to make is, should we redraw the illustration as a vector? And this will probably depend on the longevity of the graphic. How much longer is it going to be used for? So it's probably cost versus use. And does the legacy illustration still now exist in a CAD format? So perhaps you can take this out, re-export it in a vector format. So all things just to think about there with your graphics. The other option is to actually, instead of manually trace it, is to auto trace it. My own experience around this is it's not great, but it could be a good way of actually getting the illustration of better quality, but not certainly easier to edit. So I think this is where you need to do some tests on typical files. So CorelDRAW has a function called centerline trace, and Adobe Illustrator has image trace. So always worth doing some tests on some kind of generic type files, but it could actually be quicker to redraw in the end. So it's a kind of a balance between the two. And again, consider the longevity of the file. So if you do autotrace it using one of these pieces of software, then you could get a file that's very, very difficult to edit. So this is where you need to kind of assess if it's better redrawing it. And just another thing on raster is some information about kind of when you actually rotate it or resize the image, then you're always going to, in some ways, perhaps degrade the quality of it. Kind of the technical term of is called interpolation, which means basically that you're remapping the pixels either in space or in size. So you've got to be careful that every time you do that, then the quality of your image could actually degrade. So that's something worth considering before you actually do that as well. So test the file before you actually rotate it or resize it. But one of the outputs of that particular interpolation is what we call artifacts. So they can actually use to benefit you in actually displaying the illustration on electronically. So one of them is called anti-aliasing that you might have heard of. Other is blurring and halo. So by actually applying these in, say, an image editor, you can actually improve the image display on a screen. Just be careful, I think, again with that, those particular functions or filters. So we spoke about an intermediate format. So we have experience of data coming from a CAD system, for instance, where it's actually there's a raster file actually exported out instead of a vector file. So, and could be good reasons behind that. One is that there's limitations of the export functions at the time, or options. There's a limitation of your target publishing software that it doesn't accept certain formats. And also it could be historical if you've always done it in that particular way. So I'd always validate, some advice, always validate your export settings being used. It could be that you could increase the DPI, or there could be now a vector option available. So just go back and validate your process. And we did speak about photographs being used. From my experience, this was very common in the automotive industry, where you had a lot of maintenance type illustrations, trying to show things in situations that the owner or the dealer could actually identify with. So you could have a photograph that actually has annotations on it, so it's overlaid with an annotation, or actually trace. So you could have a trace, use it as a template and then trace over it. So as an illustrator from an illustration background, I would probably always say trace it, because then you can highlight relevant information, make it distinct from the background. So now we're going to run our second poll. This is do your graphics require hotspots? Very quick one. We've just votes coming in now. So I'm just watching the results as they come in. We've got 75% voted so far. And we're nearly there, I think. Quite a short one, this, so I think, Don, you might want to share them with us now, those results. So you can see there, we've got 77%, so a high percentage of you actually use hotspots in your illustrations. And a few of you are going to look to use them in the future, so that's an interesting one. So we can hide it at that point. Thank you, Don. So moving on to that, we're going to move on to the topic of hotspots, and this is really around hotspotting raster illustrations. So I think with vectors it's quite straightforward, but with if you've got raster, then it can be a bit more of a challenge. So you can use what we call optical character recognition, so actually hotspot raster illustrations. So how does it do this? Well, it identifies the text on the illustration because predominantly that's where your hotspot would be, especially for spare parts type illustrations. But there is a dependency on the quality of the text of the scan. So again, you're going to need to do some, see if it's suitable, if it's capable of hotspotting, so test that out first. So you have to determine really if the characters are sufficiently formed. So if there's gaps, pixels missing, then it's going to be difficult for the software to work. Always test the generic subset of data, and then you can use those test results. So if once you've done the test, then you could obviously convert the whole batch using some OCR software, or you could. The other two options are regenerate the text for the graphic and include that hotspot's information, or manually hotspot the raster data, so put an overlay hotspot on the raster itself. So you always have an option. So now we're going to just look at an example of how that can be done using some OCR software. In this case, it's VisX Transform. So here we have some TIFF files. We've just got a small number here. We've done the tests already on these that they're kind of suitable for OCR. None of them have hotspots on at the moment, so they're just purely raster files. So we're going to add all those files to our directory here. And we've already selected an output directory. We've created some different settings. I'm not going to go into this too deeply today because this isn't really the subject of the webinar. But basically, I can set up some characteristics, so I can say how many digits there are, maximum digits, if it's in a circle, and so forth, so to help us identify what needs to be hotspotted. And then I'm going to start the process. Should be fairly quick. So what it's doing is it's hotspotting it, but it's also at the same time converting those files into a CGM file. So just to view one of those CGMs, I'm going to bring up VisX Edit, which is a CGM editor, and I'm going to open the files up. So there was the output directory. Let's just choose CGM. Hopefully they're going to be there. And I'm going to choose this last one. You probably recognize it from earlier on. And you can see on the tree view here we have the hotspots. So if I click on them, you'll see that they've been hotspotted. I can also show them up here as well. So all the numbers here, all the callouts have been hotspotted automatically. So that saved us a lot of time. We don't have to go through that manually to achieve that. If I did have to do it manually, then let's just reopen the file, the TIFF file. Just need to go back a directory. So this was the original TIFF file. This has got no hotspots on here. So I'd then have to go through this and manually create that area for the hotspot. So you can see that's going to be a lot longer, lot more laborious task, but you can still achieve the same thing. It's obviously going to take us a lot longer to do that, and it's not a batch kind of mode as well. So there are ways you can hotspot the files, either automatically or manually. So I'm hoping you actually saw that okay. Yeah, you did. Let's go back to the slides. Okay. So now we're going to move on to vector data. So vector data can also be in a varied number of formats as raster, but I would say it's probably preferable to raster data. If it's available, you then use it. It can be scaled and the quality is maintained. So if you're going to use it in a marketing type sense, if you're going to use it for a poster or an exhibition stand, then vector is going to be the best format for you because you can scale it to any size. Also, vector can be actually anti-aliased on an electronic display as well as raster, so you can improve the screen quality by anti-aliasing as well, but that's going to be dependent on the software that you use or the viewer that you use. So vector data sources, they're probably the most common are CAD systems, the graphics software which we spoke about earlier, PDF, and sometimes technical writing software, but that's probably less common nowadays. So let's talk about CAD systems to begin with. I have a list there. I'm not going to read them all out. You'd probably be using one of these. If not, then I apologize. But there's a lot of CAD systems out there. These are mainly 3D CAD systems, although some of them obviously support 2D as well, like AutoCAD and so forth. So we're going to run our third poll. I think this is our last poll today. Don's going to share that with you. Unfortunately, we only have 5 options that we can put up there, so I apologise if yours isn't one of the 5. So obviously, if it's not there, then just obviously you won't vote. Just looking at the votes as they're coming in. Interesting, very, very well spread across all those software. There's one company going to be disappointed. Okay, I think we're there. Up to 69, so 75, sorry. Okay, and if you share those, okay, so yeah, actually Autodesk came up on the rails then and actually became 50%. So that's not kind of entirely surprising. Siemens obviously won't be very happy because they didn't get any. But interesting results though. That CATIA is very high, which I wouldn't have thought so, but nothing against CATIA, but obviously it's quite a specialist one for aerospace usually. Okay, thanks Don. You want to have that? Thank you. So just to look at the CAD file formats that are usually available, there's obviously the native files, the native formats. DWG is an AutoCAD format, but obviously it's supported in lots of other software as well. For 3D data, we're talking about things like IGES, VRML, STEP. These are all open formats, so you're going to find them in most of the CAD software out there, so you can use those to get the data out. 2D data, predominantly DXF and DWG, but you could also think about using CGM, we mentioned that earlier, and also PDF as well as export 2D formats from the CAD. You can get some good results from those formats as well. So we've got got a couple more demos to go. So I'm going to go back to VisX Edit. So what I'm going to do is open a DWG file. Just want to kind of show you some of the issues you might come across with the DWG. As we open it here in VisX Edit, you're going to see that we get a lot of information like layering information, which is obviously common in 2D CAD. So we're going to get, from an illustration point of view, a graphics point of view, we're going to get a lot of information, extraneous information that we don't really need. And plus, we're going to get the structure of the file might not be great. So we could actually do some simplification of arcs and ellipses and so forth here before we bring it in. So I'm just going to open the file with everything visible. I could actually here take some of the layers out if I want to before I bring it in. So you can see I've got all the legend, the drawing frame, pretty much everything is viewing, but I probably only want the illustration part. So I need some way of actually getting rid of that information before I bring it through. So you really need to think about how am I going to do that? Can I do it in an automated way? I could obviously do it manually. I could have eliminated the layers using VisX Edit, but that might not be possible in every software that you're using at the moment. So just something to bear in mind if you're using DWG or 2D CAD, that you might need to get rid of extraneous information. Okay, so let's go back to the presentation. So some of the considerations when using CAD, some are pretty obvious and common sense, but 3D file sizes can be challenging depending on your computer and the software that you're using. Converting files, you can sometimes get what we call polylines, little straight lines, basically, and they really pump up the file size when you actually then optimize it to go to your graphics environment. So if you go into CGM, then you're going to get a file that's a much bigger because of that. So you might want to look at trying to optimizing that. Also, we spoke about removing the extraneous information like layers and legends and text. So you really need to think about that as well. What's the best way of doing it? And the best way is obviously automatic because it's more cost effective. Also, we're thinking about editing. So Polylines not only boosts that file size up, but it also makes it difficult to edit. So it's not Bezier curves. So again, you need to think about that when you export that file out of your CAD system. It might not be possible from the CAD system to optimize it, but it could be you could get a piece of software that allows you optimization as it's actually imported. Also, thing to think about is text. Text from CAD systems can be an issue. So we could get font substitution or character repositioning. This is more of an issue when the text is probably in tight areas like a wiring diagram. So you don't want the text to reformat itself and actually cover the illustration. So this can be a big issue for a lot of companies, and I know Larson's are currently working on ways that they could actually optimize this. So from the CAD we go on to general graphics. Probably you're all aware of Adobe Illustrator and CorelDRAW. They're probably the dominant software in the graphics industry. Very good at publishing out to commercial. They've got very good commercial industry requirements, so good publishing formats like Adobe Illustrator, PDF, SVG, DWG. But if you're in a specifications-driven industry, then you're probably going to need CGM. So although CorelDRAW X7 does support CGM still, it doesn't support the profiles that specification compliance requires. There is another CorelDRAW product that does allow you to do that though. So, but you'd have to go up that path or choose the higher software. So takeaways: good choice for export formats, PDF, SVG, both open formats. I would say SVG is not a great choice as an archive format because it's still kind of you can export it easily, but actually bringing it into another piece of software can be a challenge to edit it. That is, file size is usually good, very good, and good compatibility with the publishing software. Advice: don't usually support the CGM format, at least compliance with the industry standards, and not really capable of adding hotspot information. Other than if you've got PDF, but that's not really the format we would take into an IETM or IETP, an interactive electronic technical manual. You could use TIFF as an output format, but it's not ideal. Obviously, we'd much prefer to use Vector if that's available. So from the general graphics, we move on to specialist graphics software. So this is kind of a different arena, not mass market. So you'll all have probably heard of some of the players here like Isodraw. Then there's Corel Designer X7. There's Larson software, which we were looking today, VisXedit, which is the only native CGM out of those. We've got Autotrace, Tech Illustrator, Cortona, and we've also got Antaea's Leonardo, which is actually an add-on to Isodraw and now Corel, which gives you compliance to S1000D and ATA. And then we've got some 3D software like Creo Illustrate, 3D Via Composer, and Cortona's Rapid Manual. So we've also got some good software now to actually repurpose 3D data. Although Arbortext Isodraw did or does still do that with CAD Process, and so does Corel Designer. So the specialist software is used in all areas of manufacturing, not just aerospace and defense, because you want to create those illustrations quickly and effectively. The cost is usually higher, but the payback is quicker. Very good choice of import-export formats, very good handling of 2D and 3D files, and also good compatibility with publishing software. So my advice is always look at the specialist option. Now, I did talk about PDF at the beginning, and it's really interesting how PDF has it's kind of progressed, and if you weren't aware, then it became an ISO standard back in 2008. So it's an open format now. It's not predominantly, but it's not owned by Adobe anymore. So it's governed, the releases are governed by the ISO committee. And the objective of PDF was always interoperability. So I think this new, or this stance they now have with ISO just reaffirms that. So if you didn't know, PDF was based on PostScript, the Adobe technology. So it does support graphics primitives, so things like lines and Bezier curves and ellipses and so forth. And it can also contain raster data as well. And you can open PDF in different graphics programs to edit them. But not all PDFs are equal. So you might actually find that some really old PDFs, although have an illustration in them, they might not be have a vector structure. So that would be probably an older PDF file going back quite a while. But if you've archived them, that could be the case. So just bear that in mind. And PDF, as I mentioned earlier, could be a good option from a CAD system as well as an export format. So this is the final demo. I'm just going to open, this is CorelDRAW X7. This is the standard graphics publishing software. And this is just some elements I've drawn, very basic elements. So what I'm going to do is just publish this as a PDF file. So I'm just going to save it. Okay, and then we'll go back to VisXedit again. So I've opened quite a few files in here at the moment. So I'm going to choose PDF. And there's the PDF. It even gives us a preview of the file. And we can see here all the elements are preserved. So that's interesting that you could actually use PDF as a way of transferring information and retaining the quality as well. So I think that was worth highlighting, those kind of that interoperability of PDF. Finally, this is probably not that common anymore. But there could be illustrations that are trapped inside publishing software that you would need to extract. So I wouldn't kind of give up on them if they're in there. There could be ways of getting them out, but they probably vary depending on the software, the target software. So if the original has been lost and that's the only source, then I would recommend try and look at different ways you can get those graphics out, either as a raster or a vector file. And obviously we're Larson, so CGM is an important format to us. So I would always consider CGM as a good format, as well as we spoke about PDF. So CGM's open as well. It's non-proprietary. It's got governance from the CGM Open Foundation. It can contain raster and vector, specifications compliant, interoperable, and can contain metadata. So in other words, hotspot information as well. So we've been looking at VisXedit today, so you could see that was a good way of actually looking after those files. So just in summary, I think there's a lot of opportunities to source information to create your technical graphics from. There's a number of source formats out there. We've looked at we might not have covered all of them today. If you can suggest any others that we should have looked at, then we'll be happy to hear from you. But obviously the primary considerations are always around quality, reuse and publishing. So really choose the best format you possibly can, even if it means changing. You want to always try and manage one file type. So you don't want the same file trying to manage 3 different types of file, because that could cause you configuration issues. So we hope today's been good. We're open to any questions that you might have. So I'm just going to see if we do have any. So let me just open it. And we have one question that we had a problem with the audio at the beginning. So we don't have any questions. Fantastic. Or not fantastic. Okay, so just we have kept you on for 45 minutes, so we're conscious of that. If you do have any questions post-webinar, then you can obviously email Larson, and they'll be happy to help you with any questions about software or the formats we spoke about today. So just in closing, you can discover more information about Larson at cgmlarson.com. There will be a link to recordings sent via email, probably tomorrow. That's the usual schedule. We will be uploading these slides to slideshare.net/donlarson.one. That's the Larson SlideShare site. They're not there yet, but they will be later on today if you want to download those. You can follow us on twitter.com, cgmlarson. So this is a new way we're really putting the news, or Larson are putting the news out there. So if you want to follow us, then do so. Event coming up in San Diego is the user forum, 21st to 23rd of September. So Don and Bill from Larson will be there. I'll be there as well. So if you are visiting, please make yourself known. We're pleased to talk to you. And we have another webinar, not till October though, October 2nd, which is part of an event called Manufacturing Day. So we'll be presenting a case study for McLean Engineering on that particular day. So it is a Friday, so a bit of an unusual day, but we will be running that webinar on October 2nd. So I'll just double check if we've had any questions in, and we're still good. So I'd just like to end it there. Apologize for the audio problems that we had at the beginning. So obviously we're on the internet live, so hope everything's performed well for you on the visitor side. So I'd like to thank you for attending today, and please attend one of our future webinars. It'd be great to hear from you again. Thank you very much.